I want to talk to you about motor control circuits. And this is one of the most confusing questions on the Florida electrical exam. And a lot of people miss these. There's about 6 of them on the exam, and there's a couple things I want to tell you about them, and that's going to make it a lot easier for you. So let's get started. Now, again, these are on all exams. The electrical exams, every one of them have these motor control circuits. Once you understand them, they're pretty easy to troubleshoot and figure out. They have a start button and a stop button, and a light and a relay and a normally closed and normally open contacts in them. Okay, so you've got to understand the schematic, like a drawing, what the symbols are, to be able to troubleshoot these circuits is basically what they're asking you. What happens if you press start 1? Does the light up? Does it not light up? Is the light bulb burned out? Things of that nature. And there'll be A, B, C, or D will be the choices, and they will give you different situations if different things happen in the circuit. So you basically got to start from the very beginning of the circuit and follow the current of electricity or the electron flow out from the beginning and see where it goes, see how it energizes a relay, lights the light bulb. The key here is that, and they don't tell you this, which is really, really bad, the testing center and the state licensing board, that they don't tell you this information. But the key here, and when I took my first test in Florida years ago, I took the electrical contractor's test, and I didn't realize, because they didn't give me any kind of legend or any kind of description of what's going on in the circuit, I didn't realize what was happening. And what I didn't realize was that the coils or the relays in the circuits, when they're energized, they control the contacts that are associated with them. Now, how do I know they're associated with those relays? Because they're labeled, the relay's labeled R1, and the contact's going to be like C1, okay? And it might be normally closed contact, normally open contact. And what happens is, when that relay is energized, okay, when there's current flowing through that relay, because you press, let's say, for example, the momentary button, the start 1 button, when that relay is energized, it's electromagnetic, a relay, and it pulls down a set of an armature that is attached to contacts, and it could be normally open or normally closed, and it switches the state that the contact is in. So if the contact is in the normally open mode and you energize the relay, and then C1, if you're energizing R1, is going to switch its state. So if it's normally open, then it goes to normally closed. And if it's normally closed, then what does it do? It opens. Okay, that's the key. Normally in a schematic or block diagram, you normally have some kind of a reference on the page that tells you, relay 1 is associated with these contacts or whatever. Or you have like a dotted line showing the energized relay and what it affects. But on the CRT, on the monitor, they don't tell you that, which is really not fair, actually. But I guess you're supposed to know what kind of circuits they are. I don't know how you're supposed to know that, but you're supposed to know it, I guess. So you know it now, and that's the biggest key, because when I first took the test for the EC test, and I realized that when I took the Alarms 1 test, I said, wait a minute, these are attached. Like R2 would be, R represents relay, 2 is the number 2 relay, right? R2. R2 affects, when it's energized, it affects C2. So if C2 is closed, it's going to open it. If C2 is open, it's going to close it. Okay, and that's all you need to know. And then you actually, the monitor's here in front of you, right? And as you get the question, what I usually do, I put my finger up on the monitor, and I just simple as this. I either take the negative or positive. I usually go from the negative side. If it even tells me if it's negative, I'll go from the negative side, and I'll follow the electron flow and say, okay, I'm actually writing across the screen, excuse me, as I do that with my finger, and trying to see what's going on. Rather than doing it in my head, I kind of take my finger and go across. Okay, electrons go through here, goes through the switch, goes down the wire from the switch, it energizes that light bulb. At the same time, it energizes the relay. Okay, the relay contact closes, and that now, when I release the button, the light stays on because the relay is latched, closed. And I'm going to show you some of this stuff, and hopefully you'll grasp this. If for some reason you don't get it with this short display, call me, and I'll be happy to talk to you about it, and you'll get it figured out. Okay, so let's take a look at what we got here. Now, these are some of the symbols you need to know. Okay, power source can be a battery, it can be a power supply, it can be a receptacle or whatever. It may be positive and negative, it may be a direct current, or maybe alternating current. Okay, so to the right of that, you can see the contacts here, and you've got your normally open contacts on the left. Okay, the top one's a push button, and that looks like to me a momentary button. Okay, if it's a switch that closes, it would have like a switch like that. Okay, so that's a normally open momentary button. To the right of that is a normally closed button. Okay, so those are your start buttons and your stop buttons. Okay, they allow power to go to the circuit momentarily while you're depressing it, or you interrupt the power to the circuit. That would be the stop button. Start button starts the power to the circuit. Stop button stops the power to the circuit. Okay, I'll show you this in the drawing in just a minute. Below that, you can see the switch. Normally open, normally closed. There, that's a switch. And below that, those are symbols. Right where my little arrow is there on my mouse. That's a normally open contact, okay? To the right is a normally closed contact. You absolutely need to remember that symbol if you don't already know it. Normally open contact kind of looks like a capacitor where you've got the space between. And it's easy to understand because as the electricity flows through that wire and it gets to normally open contact, if there's a space there, right, the little electrons can't flow to the other side. Okay, so that's open. It's an open circuit then, right? Just like you would cut a wire, and it wouldn't be able to pass through the air because the air has a high resistance value, right? So if it's normally closed, it's got a line through it. Okay, that line, basically is a conductor laid there that's across the contact, shows you that it's normally closed. Now, when I say normally, that means in the normal state. Okay, in its normal state. Now, if it's attached to a relay, so if you have the relay coils here, for example, right, and when the relay is energized, it causes a magnetic field here, and you have an armature at the top, it pulls it down, right? So it pulls that down. Energized, unenergized. And when it pulls it down, at the end, it has contact points. Either it opens a contact, okay, and it closes the contact. Okay, depending on what state they're in. It moves it to the opposite state. So if it's normally open, it's going to close it. Normally closed, it's going to open it. All right? So on the left, you see the relays, right? R1. Take a close look at that. R1 is a relay on the exam diagrams. Okay, they've just got a circle with an R1 there. But you can also represent it to the right, like that coil with little bars on top of it. Shows the core. And then further, you can show it as a coil with the core, and then also those are little contacts. If you look closely at that, you can see that when it's energized, it would pull down and open one of those contacts and close the other one. Okay, and then below that is the light bulb, which on the exam it's represented like as L1, L2, things like that. Okay, so let's continue on here. Let me show you these motor control circuits, and we're just calling them motor control circuits because really that's pretty much what they do. Let's look at R1 and see what it does here. Okay, we're going to start out slowly, and then we're going to work our way up because on the exam they've got these things stacked together. Okay, they got them all stacked up, and it's overwhelming a little bit because the relays are in different areas, and actually the relays are in the individual circuits, but the contacts for the relays are in different parts of the circuit. So that's how they try to get you there. Okay, so we're going to start simple here. Got a power supply on the left. You've got your current. And let's go ahead and track that. Let's go from the positive. So from the positive, and I'm literally doing this on the screen as I as I actually am taking the exam, so I don't lose track of where I am. You know, I do a lot of that on the screen stuff. I put my finger on the glass of the screen, the CRT screen, and I follow the electrons across the screen and then see what they would do and then what lights, and then I kind of put my finger on what lights and then see what else. I'm put my finger over there if that lights, and you know, I kind of do that just to keep it all in perspective because it can be quite confusing. And like I said, there's about 6 of these on the exam. So maybe a little bit more too. So you really need to master these and understand this. It's basic troubleshooting. And I know a lot of you guys and girls have been out there in the field and you know, you've had a troubleshoot system. So this should come natural to you. But the key is the relays control the contacts that have the same number on. Okay. So let's look at this then. So if I go in here and I press start 1, right? So my electron flows through. And right now it comes down, it branches off there. It goes down to the contact 1. Well, it's an open contact, so it's not going to cross the contact, right? It goes to the top. When the button is open, there's no electron flow, no electricity flow, no current flow. So when you press start 1 down, okay, what happens? Electricity flows through the wire. It goes to the light, L1, and it goes all the way back. Remember, stop 1 is a closed button, okay? You see that it makes a contact all the way back to the battery, the power source. So the L1 lights up. And what happens to relay 1? It energizes, right? So relay 1 energizes because you're holding the button down. So when you release start 1, what's going on now? Well, the relay was energized and it closed C1, didn't it? While you're pressing it down, you energized that relay, lit the light bulb, and you also close contact C1. Well, now look at that wire going across from start 1 at the beginning to the other side of start 1. That contact is in parallel with the start 1 button. So it actually, once that relay has been energized and closes C1 and that contact now allows electricity to flow through the contact back to the relay. What you're doing is you're latching that on. So when start 1 is pressed, the relay energizes and closes C1, which now electricity flows through C1. So when you release the button, it doesn't matter because C1's already closed, right? So you're latching that relay on is what you're doing there. Now, how do you stop that? How do you just stop that circuit from lighting? You would press what? The only option here is take the power supply off of it, right? You could disconnect the power supply. It would make the relay de-energize. It would make the light bulb go out. Or you can press stop 1. Stop 1 is going to open the circuit. It opens the power back, you know, to the battery or from the battery, and it de-energizes. Okay. Once the relay de-energizes, the contact opens up, and you would have to press start 1 again in order to get the flow. Now look at the top representation here. And look at the bottom representation. Okay, you can see there's different symbols I drew here. I've R1, a little coil, it kind of shows you a physical example of the relay, and above it, it shows you a circle with R1 in it. Okay, that's the way it is on the exam. The circle in R1 and L1, it shows a light. But I just wanted you to see a kind of a physical representation of the same circuit. Makes it a little bit easier to understand, okay? Because L1 is a light, R1 is a relay, okay? So the top and bottom circuit are the same, all right? And really, if you understand that, these questions are a breeze to get. You know, they take a little bit of thinking. I mean, you got to do the tracing and everything else, but they're a whole lot easier, and you get a different answer if you didn't know that relay was controlling those contacts, right? Because you would get a different answer. So here you go. I just got another representation here of what happens when you press, you know, you got the non-energized here, so forth. Okay. If you go ahead and press the button, then L1 lights up. Okay. And you can see C1 closes. It's represented that in red. And then when you release start 1, current is flowing through C1 because you've closed it here originally, energized the relay, and you're good to go. Now, they could show it to you something like this, where you have you don't actually look the power supply is assumed, okay? You just got a couple lines coming in here, wires coming in here. You're to assume that's a power supply there, okay? And this is an example here when the relay is energized, boom, closes the contact here. And it's just drawn a little differently. And that's one thing you can't let it confuse you, the way they draw it. That's why it's nice to trace it out with the electricity, electron flow, and trace it to all the wires and see where it goes. This is the same circuit as before, just drawn differently, okay? You can see power comes in. Let's say this right here is a negative. Electricity flows through here. When this is pressed down, okay, normally it's not pressed. The red means it's activated. When this is pressed, what does it do? It comes through here, right? I mean, it can go down through here too. It doesn't really matter. I mean, it's going to come through here, right? Going to go through here back to the other side, and it's going to come down through here and go through here like the light bulb. So once it comes through here and energizes the relay, what's going to happen? That's going to close, right? The C1's going to close. And then when you let off start one, all right, the electricity is still going to flow through the circuit because it's flowing through the contact. The only way to stop it would be to press stop one. Now, I put the stop one up here. Before, you could put it down here, you know, you could put it over here. It doesn't matter where you put it, really. Here, anywhere along this circuit right here would work. Or even up in here would work, you know. You're just interrupting the current flow to the relay, not to the light, to the relay, okay? Once the contact is open, then you've lost your circuit. Now, this is where they kind of make it more tricky. They start stacking these up on top of each other. And when they do that, it gets more complicated. Because here's a situation where you've got relay 1, L1 is there, C1 is here. These are basically this circuit just piled on top of each other. But if you notice, start 3 all and C3, they're all in order here. All right. So each one of these is independent circuits. I mean, if you look at this, it's an independent circuit. Everything on the end goes back to, let's just say that's the positive. Let's say this is a negative. It flows down through here. Energize start 1, right? Energizes R1. What does R1 do? Closes C1. Light 1 latches on. Here, that's the only light that comes on. Here, start 2, you energize, push that down momentarily, start 2 button, electricity flows through here, right, goes through here, energizes relay, closes C2, latches power on. The only way to undo that would be to press stop 2, drop it out. So these are all just stacked on top of each other, that's all they are. Okay, neither one of these circuits affects the other circuit. But what happens is they kind of do something different to you. They take the relays, and the relays are in the right circuits, right? Relay 1, relay 2. Well, I guess I've got it a little bit different here. Because I wanted to show you they could do this also. I'm not sure if they do this or not, but this will kind of give you an overview of understanding the complexity of these circuits. Okay, so here we got, let's say, start 1, right? Start 1 is energized here, right? If you press the button, that's what the question is going to have. It's going to say, if you press start 1, what's going to happen? Then it's going to say A, B, C, or D. A, you know, L1 lights, L3 lights, L3's supposed to light, but it doesn't light, so it must be burned out, you know, stuff like that. They just give you a series of things that happen. And actually, if you follow it with your finger and you figure it out, it's pretty easy. It just takes a little time to figure them out. So in this case, start 1 is pressed, R1 is energized, and R1 energizes C1. So what's going to happen here? When this is pressed, the question is, what happens when you press start 1? Start 1 is pressed, R1 is energized, C1 is going to open, right? Okay, C1's going to open, which doesn't mean anything in this circuit, but C1 opens, C2 opens, right? Wrong, C2 doesn't open because it's not associated with R1's relay, right? What associates R1 to C1? It's the 1. So C1's down here, that opens. Is C1 anywhere else here? Nope. So what's going to happen if this thing's energized? Only thing that's going to happen is L1's going to come on, because that's going to open and that's going to open, but none of these other things are energized here. So what happens when we press start 4? Okay, and the question is, what happens when you press start 4? Start 4 energizes, you got your power coming down through here. Remember, all these are open right now. So none of these things are doing anything. But if you press start 4, you're going to energize R4. If you energize R4, C4 is going to close, right? Well, that means L4 is going to come on. But R4 is also, where else is R4 in here? Anywhere else? R4, when I say R4, I mean C4. Yeah, I don't see, C4 is over here. Well, that closes, we got that one. So that's all that's going to happen there. But if C4 were somewhere else, it might have an effect. Let's continue on here. Let's press start 2. Start 2 is energized, right? Electricity goes through here, through here. It energizes R3. Okay, that's closed already, right? Because that's normally closed. It's normally closed contact. Okay, so electricity flows through there. And C2 is going to, C2 is not going to close, is it? Because C2 isn't tied to that relay. So you energize R3, and R3 is going to close C3. Oh, okay. R3 is going to close C3, right? Okay, so let's take this the time. You momentarily press start 2. R3 is going to energize. C3 is going to close. That's going to power R1. The light bulb's going to come on. R1's going to close. It's going to open C1. Now, in that case, you're going to have maybe a flash. The light's just going to flash. Because, but when it comes back to this relay, when R1 opens C1, it's going to drop the power off to R3. Okay, it's probably not a very good example, but this is the kind of stuff you've got to think about, because these relays control these contacts, and it could be in other parts of the circuit, and even the relays could be in other parts of the circuits too. So they might not be in the same circuit as start 1. You could have relay 3 and so forth, and they could control contacts in other parts of the circuit, moving them to their opposite state if they're energized, right? Okay, let's take a look at this one. Start 2, that's where we were before. So start 2 energizes relay 3, closes C3, closes C3 there. C3 energizes R2, so closes C2, and R2 closes C2 over here, but it's going to open C3 here because you're energizing R3. But so this is what we're talking about. So R3 also, I didn't draw that in, R3 also closes C3 here. So this is going to light, L1's going to light too, right, also? Yeah, because if you power that, that should close C3, and that's going to light as well. I don't believe they're going to be as complicated as I'm making them. But I want you to understand what's happening here and what you have to look for, okay? So let's take another one here. And which lamp light starts when you press start 5? So S5 here. So we press S5. Let's see, electricity comes down through here, current flow. Remember, all these other ones are open. Got a little bit of different, some funky stuff going on up here with contacts. But let's go down here. Start 5 energizes R3. Okay, what is that? L5 is what? The light bulb number 5, okay? So R3, and then this is important because L5, you got to make sure L5 is part of your answer. Even though you're pressing a different start number in some cases, L5, you want to make sure you've got the right light number and the right contact number. If they say something like that, as they say, contact so-and-so closes or opens or whatever they might say. Okay. So here we go. You energize start 5. Power comes through. It energizes R3. In fact, I think I have it over here on the next screen. Let's just make it easier on us. All right. Start 5. It energizes R3. The relay is going to be energized, thus changing the state of any contacts that are numbered the same. So R3 changes the state of C3. It opens that one, closes that one, closes that one, closes that one, and closes that one down there. Of course, when it closes this one, it energizes R5. R5 closes that one down there. And when it closes this one up here and that one up there, either one, it's going to energize R1 too as well in light one. So those are the 3 lights that are going to come on. All right. Now, that may be more complicated than what you're going to get on the exam. But if you understand this, you'll have no problem with the exam. But again, I'm pretty familiar with these circuits, and I've troubleshot a lot of circuits over my years in the field. And it's just a matter of thinking about, and I always do this, and it's very simple. I think about the way the electricity goes through the wire, all right? If it's a switch, and you press the switch closed, then it goes beyond the switch, and then where does that current travel? It's always got to go back to the source, right? So you can't have an open going back, but as long as you have a closed loop going back to the source, then that electricity is going to flow through that circuit. If it flows through the circuit, then what's going to happen with the circuit? It's going to light a light bulb. It's going to energize a relay. If it does energize a relay, then there's contacts attached to the relay, and those contacts are going to either, whatever state they're in, when they get energized, you're going to change them to the other state. So if it's a normally open contact, it's going to go closed. If it's a normally closed contact, it's going to go open. All right? That should help you quite a bit on the exam. Just remember, they're not going to tell you those relays are connected to those circuit or those contacts in the circuits. That's the key. You've got to take that with you to the exam, and you'll do wonderful.